Hi viewers, this is a problem to explain analysis of synchronous sequential circuits. The problem that I have taken as an example is to analyze for dA is equal to A bar Bx, dB is equal to x plus A bar B, Z is equal to ABx. dA, dB are the flip-flops, x is the input to the circuit or flip-flop, Z is the output. So I have again given here the inputs to flip-flops are dA is equal to A bar Bx, dB is equal to x plus A bar B. So how to solve it? The step number 1 is to do the logic diagram, then the next state equation or the characteristic equation. Here it is given dA dB, so we understand it is a D flip-flop that is used. And then the state table, reduced state table and the state diagram. So first let's see the logic diagram. So the logic diagram, you can see there are two flip-flops A and B. So dA, dB are the inputs to the flip-flops and dA is given as A bar Bx in the problem. So we need an AND gate. So there are three inputs, A bar, I have taken it from the A bar and given it to the AND gate, and X and B. So you can see it very clearly and you can do it by yourself. dB is X plus A bar B. So we need AND gate and an OR gate also. So Z is the output and Z is equal to ABX. That I have not given it here. I have just given the inputs to the flip-flops. If you want, I will write it later. So Z is equal to, it is given in the problem ABX. So A, B and the X. So this is the way to do the logic diagram. And next is going to be the characteristic equation or next state equation. The next step is to write the next state equation or characteristic equation. Here we are using a D flip-flop. We know in a D flip-flop the output follows the input. That is, the next state is equal to the present state or the input. So if we take the present states as A, B and X, then the next states to A and B can be taken as A n plus 1, B n plus 1. So here, therefore, A n plus 1 is equal to A. What is your dA? Input to the first flip-flop. So what is the input? We know the inputs are, for the first one A bar Bx, for the next one X plus A bar B. Therefore, the next state A n plus 1 is equal to A bar Bx because the output of the first flip-flop follows the input. Then B n plus 1 is equal to X plus A bar B. Okay. So the present state, next state is equal to the current state in a D flip-flop. So the characteristic equation is done. And then next is the state table. In a state table, we know it gives the relationship between the next state with the present state and also the output. So here we know there are three inputs A, B and X. Therefore write the inputs in integral powers of 2. That is 2 power 3 is 8 combinations. So it is 0 to 7, 8 combinations. And substitute the values of A, B, X into the expressions given in the problem. What are the expressions? dA, dB is equal to A bar Bx and X plus A bar B respectively. Z is equal to ABX. Substitute into that and find out the values of A n plus 1 and B n plus 1. Okay. So we know the input is equal to the output, that therefore we substitute in the same expressions and find out the next state. And coming to the Z, that is also substituted. Z is equal to ABX. Shall we see any one column? Shall we take the last one? What is A n plus 1? That is equal to A bar. A bar is 0. 0 into anything is 0. So therefore the last one is 0. And then for B n plus 1 it is X plus A bar B. What is X? 1. A bar is 0. So 0 plus 1 it is going to be 1. Okay. So the next one will be doing your state diagram. Before we go for the state diagram, there is one more step, that is the reduced state table. That is the step number 4. So how to write the reduced state table? It has the present states, that is A, B. Next states A n plus 1, B n plus 1. Take it and write it separately for the inputs x is equal to 0 and x is equal to 1. And then the output z for x is equal to 0 and x is equal to 1. So now if you look into the state table, for the inputs A, B 0, 0 and for x is equal to 0, what are the values? The next state values are 0, 0. So write it here. The next state values are 0, 0 for x is equal to 0, for the present state values 0, 0. If you come to the next one, for present state A, B equal to 0, 0, for x is equal to 1, what are the values? It is 0, 1. So write it here. For the present state value 0, 0, for x is equal to 1, it is 0, 1. Similarly, look into the third column, 0, 1, A, B values for x equal to 0. The next state is in the third column 0, 1. So write it here, 0, 1. And then next it is fourth column, 0, 1 for x is equal to 1. The values are the 0, 1, 0 and 0, 1 for x is equal to 1. The values are 1, 1. So 0, 1 adjacent to A, B 0, 1. Write the values as 1, 1. Okay. So let's check for the last one. A, B values 1, 1 for x equal to 0. It is 0, 0. A, B values 1, 1 for x equal to 0. It is 0, 0. And the last one. A, B values 1, 1 for x equal to 1, it is 0, 1. So A, B values 1, 1 for x equal to 1, it is 0, 1. Similarly, the outputs also. What is the output? You can observe here, z is equal to 0 for all the values of A, B and x except for the last one. What is the last value? A, B is equal to 1 and x equal to 1. For that alone it is 1. So substitute that. A, B 1, 1 for x is equal to 1, it is 1. The rest all are zeros. So it is easy to fill. Okay. So this now our reduced state table is done. Now we have to go for the state diagram. If you leave off the reduced state table, the state diagram is going to be very big and you cannot do it without mistakes. So we go for the reduced one. The last step is the state diagram. The state diagram helps us to identify the circuit's response to particular set of inputs. It clearly shows the transition of states from the present state to the next state and output for a corresponding input. So the state diagram should be done with a prerequisite understanding that the given circuit is a Mealy model. Why? I have given it in the reference. The output is a function of input. Z is dependent on the input. Therefore, the given circuit is a Mealy model. So how to do the state diagram? It is done from the reduced state table, the previous step. So here we see there are four set of pre-states, 0, 0, 0, 1, 1, 0, 1, 1. So if you consider the first pre-state 0, 0 and the next state for x equal to 0, it again goes to 0, 0. So it is a self loop. You can see here, write the present states inside the bubble 0, 0 and for x equal to 0, it goes to again a n plus 1, b n plus 1. The values are 0, 0. So it is a self loop. Put a self loop. For values x equal to 0 and what is the output z for x equal to 0? It is also 0. So the format should be written like input by output along with the loop. You can see there 0 by 0. And then next one it is going to be from 0, 0 for x equal to 1, it goes to the next state 0, 1. So you can see here an arrow from 0, 0 it goes to next state 0, 1. For that what is the input? X is the input x is 1. Okay, so for 1 it goes to 0 1. So from 0 0 it goes to 0 1. Input is 1, and what is x equal to 1 in the output? It is 0. So write 1 bar 0 or 1 slash 0. So the first one is done. So next it is the 0 1 state. So this is the 0 1 state. From 0 1 it goes to 0 1 for x equal to 0. So that is also a self loop. For x equal to 0, what is the value of output? That is also 0. So write input by output 0 by 0. And for x equal to 1, what is the value? It goes to 1 1. So from 0 1 it goes to 0 1. Okay. So what is the input and the output? X equal to 1. Output is always 0 except for the last one. So you write a 1 slash 0. Next state is going to be 1 0. Similarly, see the fourth step, 1 0. What are the values? For x equal to 0, it is 0 0. It goes to 0 0 state. For it goes to 0 0 state. You can see here. Okay, there is no self loop here. So input by output 0 by 0. And what is the other state? For 1 and 0 pre-states, it goes to 0 1 for x equal to 1. So take it to 0 1. The input x is 1, output is 0. Similarly for the last one, 1 1, it for x equal to 0, it goes to 0 0. X equal to 1 goes to 0 1. So it goes to 0 0, then it goes to 0 1. I have given it at the last, the outer loop. Okay, so for that only the output is 1. You can notice here 1 comma by 1. Okay, for all elsewhere the output is 0. So with this the problem, the analysis gets over. This is the state diagram with the circuit considered to be a Mealy model. It has to be done this way. So if you like it, please put a comment in the box. If you have any doubts also, share it in the comment section. Thank you.